right. On the last lesson, we talked about these four types of angle pairs or relationships. When we had two lines intersected by a third line, remember we called this line up here the transversal. And so now we're looking at specifically in this lesson, we're looking at what happens when I have parallel lines and a transversal. So these corresponding angles, there's a theorem called corresponding angles theorem that would say that your corresponding angles are congruent if you have parallel lines. So in this example here, angle 1 would be congruent to angle 5, because those would be corresponding. Angle 2 would be congruent to angle 6. Then you would have angle 3 would be congruent to angle 7. And you would have angle 4 would be congruent to angle 8. Okay? So again, this is only with parallel lines. Corresponding angles are going to be congruent. Alternate interior angles, those are also going to be congruent. So again, if you have parallel lines, angle 3 would be congruent to angle 6. Angle 5 would be congruent to angle 4. And then for alternate exterior angles, those are also congruent. You would say angle 1 is congruent to angle 8. And then the other pair, you would say angle 2 is congruent to angle 7. Okay? So if you have parallel lines, these three angle pairs or angle relationships, you would have congruent angles. Now the consecutive interior angles, those are going to be supplementary. So this would be angle 3, or the measure of angle 3, plus the measure of angle 5 would equal 180 degrees. Okay, then you would also have on the other side, you'd have the measure of angle 4 plus the measure of angle 6 would also be 180 degrees. Okay. So these three, again, just as a review, corresponding alternate interior, alternate exterior angles would be congruent if you have two parallel lines cut by a transversal. Consecutive interior angles with parallel lines, you would have supplementary angles. Okay, example 1 says the measure of 3 of the numbered angles are 120 degrees. Identify the angle. So we have two parallel lines intersected by a transversal. And I know this angle up here on the left is 120 degrees. We need to find out which other angles also have that 120 degree measure. Okay, so to start off, I know that this 120 degree angle and this angle 4, those are congruent because they're vertical angles. So we would say the measure of angle 4 is equal to 120 degrees, and we'd say by the vertical angles theorem. Okay, since we know vertical angles are congruent. Once we know 4 is 120, we could say 4 and 5 are alternate interior angles, and alternate interior angles are congruent, so that tells me that angle 5 is also 120 degrees. And we would say, let's abbreviate alternate interior angles. Okay. The other one that we can say is 120 degrees would be this angle 8, because 4 and 8 would be corresponding angles. Okay, so this 120, this 4, 5, and angle 8 are 120 degrees. Okay, so these are the three angles that are equal to 120 degrees. Alright, example 2 says find the value of x. And looking at this example, I have two parallel lines, A and B. So we can use our angle relationships to come up with a way to solve for this x plus 5. Looking at this right here, I have this angle 4. I know that this angle 4 and this 115, those are vertical angles. So that tells me that the measure of angle 4 has to also be 115 degrees. Now looking at this angle 4 and this x plus 5, those are consecutive interior angles. So I know if I add the measure of angle 4 plus this x plus 5, that has to equal 180. So let's do that. Because angle 4 is 115, let me write it back up. Let's see. So I know the measure of angle 4 plus this x plus 5 has to be 180 degrees because we have consecutive interior angles. And from these vertical angles, I know that angle 4 is 115 degrees, so I can substitute that in. Okay. And I combine like terms. It tells me that x plus 120 is 180 degrees. And if I subtract the 120 from both sides, I get that x is equal to 60. Example 3 says find the value of x. For this one, we got to look at what we have. We have two parallel lines, C and D are parallel. I want to get to this thing right here, the 7x plus 9. Looking at the 136 and the 7x plus 9, those are not corresponding, so I can't use my corresponding angles theorem. But I do have this angle 1, and I know angle 1 and the 7x plus 9, those are alternate exterior, and I know alternate exterior angles are congruent. But I don't know angle 1 yet. What I do have right here, though, is I have a linear pair. And so that I know then that the measure of angle 1 plus the 136 has to give me 180 degrees. So to find the measure of angle 1, I have to subtract 180 minus 136, and I get that that's 44 degrees. Okay? Now that I know this angle 1, now I can set my 7x plus 9 equal to 44 degrees because these are congruent, and angle 1 we just found out was 44 degrees. So 7x minus 9, minus 9 from both sides, that gives me 35. And if I divide by 7, that tells me x is 5. And that's what we were looking for, so we're done. Alright, example 4 says when sunlight enters the drop of rain, different colors of light leave the drop at different angles. The process is what makes the rainbow. For violet light, the measure of angle 2 is 40 degrees. We want to find the measure of angle 1. Alright, so what's the measure of angle 1? Well, since I have the two parallel lines, I know that angle 2 and angle 1 are alternate interior angles, which means alternate interior angles are going to be congruent. So that tells me that the measure of angle 1 is equal to 40 degrees because of the alternate interior angles theorem.